Sample problem 4.16 says that a 50 milliliter sample of hydrochloric acid is titrated with 0.1524 molar sodium hydroxide. The burette reads 0.55 milliliters at the start and 33.87 milliliters at the end point. Find the molarity of the hydrochloric acid solution. Now, titration reactions, these are very handy when you're trying to find the concentration of some unknown acid. Let's say you got some acid sitting around and you need to know the concentration of it. And you know the concentration of the base, you can do these titrations to figure that out, and I'm going to show you what I'm talking about. When an acid neutralizes a base, right, that just means that their concentrations are going to be equal. Okay? They're neutralizing each other. So let's see, what am I going to do first? I'm going to write down a balanced chemical equation to show you what I'm talking about. So if I'm taking HCl, which is a strong acid, right, AQ, and I'm adding sodium hydroxide to it, which is a strong base, that's going to yield water, right? That's why it's being neutralized, because we're forming water, plus sodium chloride, NaCl. So essentially we're just making salt water, right? Which, again, that would be AQ. So there's my equation. It's already balanced out. If we check it, it's already balanced. So let's see. I know that I've got 50 milliliters of my HCl. Okay. 50 milliliters. So that's going to be part of my molarity, right? Because molarity is equal to moles of solute divided by volume of solution. And I already know my volume, right? Volume is equal to 50 milliliters. I'll have to convert it to liters, but that's okay. We can do that by dividing by 1,000. I need to figure out my moles of HCl. So let's see. I've got a balanced equation that will relate sodium hydroxide to HCl, right? They're a 1-to-1 molar ratio. And I know the volume, or I can figure out the volume of the sodium hydroxide that I used, right? The burette read 33.87 at the end of the titration, and it started out at 0.55 milliliters. So if I just take the difference between those two, then I get my volume of sodium hydroxide that I used. And so let's see, what is that going to be? That's going to be 33.32 milliliters of sodium hydroxide. And now I can convert that to moles, right, using my molarity. They told me the molarity, but I first got to convert it to liters. So 1,000 milliliters in 1 liter. And now my molarity, they told me that in 1 liter there was 0.1524 moles of sodium hydroxide, NaOH. See? Right there. 0.1524 molar, same thing as moles per liter. All right, let me check my units. I've got milliliters divided by milliliters, liters divided by liters. I'm going to be left in moles, which is good. That's what I'm looking for. All right, let's do some math now. That equals 0.32, sorry, times 0.1524, and then that gets divided by 1,000 equals, so I got 0.0051 moles of sodium hydroxide. And now I can convert that to moles of HCl. So 0.0051 moles of NaOH. For every 1 mole of NaOH, I use 1 mole of HCl. Where did I get that from? That's the question, right? Check out the balanced equation. For every 1 mole of HCl, there's 1 mole of sodium hydroxide. There's my conversion factor. Moles divided by moles of sodium hydroxide cancel. So that means I've got 0.0051 moles of HCl. And if I want to figure out the concentration, it's moles divided by liters, right? So moles divided by, if I've got 50 milliliters, that's the same thing as saying divided by 1,000, right? Because there's 1,000 milliliters in 1 liter. So that's going to equal 0.05 liters. So divided by 0.05 liters, what do I got? So that divided by 0.05. I've got 0.102 molar HCl. There we go.